Welcome everybody to question 3, which is a little bit trickier. It's a bit of expansion, then a little bit of integration. So it's not too bad, but it's a little bit trickier. So let's dive right in with question A. So we have this expression here, this 2 plus x squared all cubed, and we need to get it into this long form. So we need to expand the bracket. So let's write it out as we know it, so we can make it a little bit simpler by, instead of writing a cube there, we can just write it out 3 times. So let's do it in different colours. 2 plus x squared, and in green 2 plus x squared. So I haven't changed anything there, I've just written it out 3 times instead of writing the cubed there. So as you would when you have 2 sets of brackets that you have to times together, just do the same with 3 brackets that you times together. So let's times 2 by 2 by 2, which is 8. Then let's go for green again. So then we go for 2 times x squared, so plus 4x squared. Then we can go again, we can go 2 times x squared times 2, so that'll be another 4x squared, and then finally for this 2 we can times it by x squared times x squared, so plus 2x to the 4, because x squared times x squared is x to the 4, so 2 times that is 2x to the 4. So now we've done 2, so let's cross out 2. We have done 2. So let's move on, move down a little bit. So we have this here, so then we can go plus, and then we can do the same thing for x squared. We can times it by everything there and get all the combinations, and we should end up, we've got 1, 2, 3, 4 terms there. We should end up with 4 terms again. So if you've got 3, you're wondering, have I got all of them? Probably not. Go for another one. Make sure you have the same amount of terms both times. So let's do it. Let's do x squared times by 2 times by 2. We just did that, so it is, did we just do that? No. Let me go back one. Back, right. X squared times 2 will be 4x squared. Then go plus. So x squared times 2, we've done that. So x squared times 2 times x squared. So that will be plus 2x to the 4. So we've done x squared times 2, x squared times 2 times x. So we've done that one as well. We don't need to worry about that anymore. Right, a new colour, purple. So then we can go x squared times by x times by these two. So x squared times by 2 is plus another 2x to the 4. And then finally we've got x squared times x squared times x squared, which is x to the 6. Make sure you don't put x to the 8 there, it's very tempting to do that, especially if you're trying to rush it in an exam, but be careful, it's just 2 plus 2 plus 2, because when you times indices you add, well, when you times x's you add the indices together, so you already know that. So let's group all these terms together. We've got an 8, let's leave that 8 on its own there, so 8 plus, and then let's do the x squared, so we've got 4 plus 4 plus 4, so that's going to be 12, so 12x squared, go for red. Then we have the x to the 4, so we have 2 there, 2 there, and 2 there, so it's going to be plus 6x to the 4, and then finally we are going to have our x to the 6, so plus x to the 6. So I think, if I'm not mistaken, that has answered our question. Our question was, show that p is equal to 12. Well, down here, p in front of the x squared is 12, so we have done that. And find the value of the integer q. So q is in front of x to the 4, and we have it as 6. Excellent. So, with that in mind, hence find the integral of our expansion over x to the 4. So let's go down there. You can just bear that in mind so I don't have to rub all this out and start again. We're going to do the integration of what we have just found over x to the 4 dx. So with this integration, you can think of this integral sign as like the opening of a bracket, and then dx there is like the closing of a bracket. So just a bit of background there so that you understand why it's there. You don't really use it for A levels particularly, this dx thing, but just put it there as a formality, I think. So, right, now, there's a few ways to do this. You could try by parts, and you'd come unstuck. You could try by substitution, which would be incredibly difficult. Or you could start by putting every term individually over x to the 4. So if we have here, we have the integral of 8 over x to the 4 plus 12x squared over x to the 4. Let's write it in. 12x squared over x to the 4 plus 6x to the 4 over x to the 4 plus x to the 6 over x to the 4, and dx for formality's sake. Right, let's simplify that. So here we go. So 8 over x to the 4 stays the same, plus 12. Now the x, that can cancel out with this. So we've got an x squared divided by an x to the 4. So that just becomes x to the 2 down there, x squared underneath there, because what you've effectively done is gone 2 take away 4 to get minus 2 on the top. So when you take it to the bottom, it becomes a 2. So we'll explain that in a minute. Don't worry if you didn't really understand that. It'll become perfectly clear in a moment. So 6x to the 4 over x to the 4, they cancel. Simple as you like, becomes 6. Then plus x to the 6 over x to the 4, which is x squared. Lovely. Right. Let's go another step. Let's go one more, so that what we can do is bring this x to the 4 onto the top. And the way that we do that is we put a little minus in front of the indice that it had, the number 4 there. So let's do that with all of them. So we could say plus 12x to the minus 2 plus 6 plus x squared. We don't change the 6 and the x squared because they weren't over anything. They weren't a fraction. Right, and then regular integration. So let's move down a bit more. I'm getting very long this. So integration. So increase the power by 1 and then divide by that. So 8x to the minus 3 over minus 3 plus 12x to the minus 1 over minus 1 over minus 1 plus 6x to the 1 over 1, I'm not going to write that in, plus x to the 3 over 3. So that is it. Let's tidy it up a bit, I think. I don't know if they require you to do this or not, but it sort of makes sense to do so. So minus 8 to minus 3 over 3. You could even bring the x down at the bottom. I mean, I'm not going to do that now because I might be wasting some people's time, but you could do that if you felt like it. And then we have, that's not a plus there. I shouldn't have done that. I was talking too much. Let's get rid of that. That plus, that becomes a minus 12 to the x minus 1 plus 6x plus x cubed over 3, or a third x cubed, whatever you like. So that's our answer. That is our answer to question B part I. Quite long and quite annoying, but never mind. Let's go way back to the top. Let's get rid of all of this. Long way up. So get rid of that. Get rid of that. Actually, you know what? We'll get rid of this bit down here and we'll keep that on the top. Keep that bit. So if we go right back, here we are. So hence again, they love hence. Hence means use what you did before. So hence find the exact value of what we just did, but between 2 and 1. So when you integrate, you find the area under the graph. If you have a random shape like this, like that, then what they're asking you to do is go between here is, say, here's number 2, and there will be number 1, and they'll say, what is this area in there? So we are finding the area between 2 and 1. So the way that we do that is we take what we just did, we take that integral there, and that's 2, and this is 1 here, between 2 and 1. So what did we have it down as? We had between 2 and 1. Let's do that because we did integrate it, so let's use what we did. So minus 8x to the minus 3 over 3 minus 12 to the minus 1 plus 6x plus x cubed over 3. So between 2 and 1 we have to do that. So the way that we do that is to plug the number 2 in, get a number, and then plug number 1 in and use the number 2 minus the number 1 to give us our area. So let's put number 2 in where x is. So there you go, so number 2. So if x is 2, then we have minus 8 times by 2 to the power of minus 3. So I think it's easier actually if we take that minus 3, if we take that down here and make it an x cubed, then we have, I'll show you what I'm going to do. We're going to go minus 8 over 3 times by 2 cubed. Okay, and then we're going to go, we'll do the same with this one. We'll do the same with all of them actually, just to make it easier. So we've got minus 12 over 2 to the power of 1. I'm not going to write the power of 1. Then we go plus 6 times 2, which is 12, plus 2 cubed. 2 cubed is 8, so 8 over 3. So that is what we get for number 2. Should we simplify it? I think we should simplify it. So for number 2, this is exactly the same. Number 2, we're going to go for this 2 cubed will become 8, so we can cancel the 8 and the 8. And we're going to get minus 1/3, minus 1/3, minus 6, plus 12, plus 8 over 3, which is also equal to, there we go, so let's deal with the integers first. So 12 take away 6 is going to be 6, and then plus 8/3 minus 1/3 is going to be plus 7/3. So plus 7/3. Let's leave it like that for now. You'll see why in a minute, because when we put a number 1 in, so we've got our number 2, we've got the number 2 there, that's our number 2. So when we put number 1 in, we're going to get another number similar to that. We're going to get an integer plus something over 3. So let's put 1 in, the same as we did with number 2 there. And what we are going to get is, the indices help us a little bit here because it doesn't matter what the index is when it's a 1. So we're going to get minus 1 over 3. Are we going to get minus 1? No, we're not going to get minus 1 over 3. I'm lying. We're going to get minus 8 over 3. We have minus 8 over 3 minus 12 plus 6 plus 1/3. There we are. So that's our thing when we put number 1 in. So let's make that a little bit neater as well. So we've got minus 6 plus 12, so that's going to be minus 6. And then we've got minus 8/3 plus 1/3, so minus 7/3. So actually, pretty much the opposite of what we had up here when we put 2 in. So let's take what we got with number 2 and Oh god, I'm going to run out of space here. So let's take what we had in number 2, which is 6 plus 7 over 3, and then take away what we got from number 1. So let's go for it. So 6 take away minus 6 is going to be 12, and 7 thirds take away minus 7 thirds, so add 7 thirds is going to be plus 14 thirds. So 12 plus 14 thirds, so you could say that that is 16 and 2 thirds, or you could say that it is 50 thirds. Is that right? Yes, 50 thirds. So 50 thirds is our area between 2 and 1. So that was a very long and difficult question. So don't worry if you struggled with that. I will see you on the next video.